electromagnetism. So today we will go through the course information. By the end of the course, you should be able to define electricity, because here you will learn about electricity. I understood that you have already came across electricity at home. You played around with your electrical devices. So, but now here you will learn about electricity in more detail, in a more physics way. So, for example, I'll explain in terms of the electric field, the electric potential, and so on. And then the next one is to illustrate the physical phenomena regarding electricity. I think this is straightforward. So meaning to say, once I have explained about the theoretical stuff to you, or once I have explained everything about electricity and magnetism, capacitance, so you should be able to apply that or explain any phenomena. For example, the lightning strikes on the ground. That is due to the electric potential. So I'll teach you about electric potential, but of course I'm not just going to talk like the famous popular physics or gravitational wave. No, I'm not going to do that. You will go through the mathematical description. So this is a starting point to a mathematical intensive learning, and then finally you should be able to attribute principle of electricity and magnetism to solve a given problem. So. Well, of course, the problem should be coming from your life. You know, for example, when you finish studying physics, maybe you came across, I don't know, the rice cooker. It is not working. Maybe it is due to capacitor and whatsoever. Oh, I've learned capacitance in ZCT 102. Okay, for example, I'm giving you an example. You know, the ceiling fan. At some point, if you are lazy to wash the fan blades, the fan will eventually become slower and slower and slower. So that's the problem. In order to solve that problem, you have to do something. You have to repair your fan. Of course, you have to repair. But what should you do? Normally, people will just call an electrician and then ask him to repair the fan. But once you have learned ZCT 102, I will teach you about capacitance. So what you need to do is you need to replace the capacitor. And then you just find the capacitor for the given fan. But you need to specify the type of the capacitor, okay? There is some spec. When you use your computer, we have specs, like for i7, but for a capacitor, it is quantified by using farad, F-A-R-A-D, which is the capacitance, C-A-P-A-C-I-T-A-N-C-E, capacitance. So you just need to replace the capacitor of that particular fan, and then it works. The reason why it works because you have learned 102. So that is one of the examples of the third point. The four fundamental forces. Okay, in physics we have four fundamental forces. So the first one is of course the strong nuclear force. So this particular force, okay, it binds all the protons and neutrons together so that the nucleus itself is stable. If we don't have the strong nuclear force, then we will disappear in seconds. No? So we need the first one to pull all the neutrons and protons and the electrons together so that they stay put in a confined space, which is the atom itself. And then we have the weak nuclear force. This is related to my research, where I've studied the disintegration of nucleus over time. You know, the decay equation. I don't know if you still remember this, but I suppose you have learned this during your Form 5, you know, the exponential solution, that one. So that is the weak nuclear force, which governs the radioactive decay and nuclear fusion. We have fission and fusion. Fission means the nucleus itself disintegrates into two or more daughter nuclides. And then we have the fusion, where two or more nuclei, the plural of nucleus is nuclei. They bind together, forming a daughter nuclei. That is fusion. But for this particular course, we are focusing on the electromagnetic force. So it is mediated by photons. Okay, I'll explain the reason why. Or maybe along the way, while studying 102, you will understand why we are governing photons here. So the force is due to the photon, which is the photon itself the photon itself consists of electric field and magnetic fields. I've mentioned this before in 103. But in this particular course, we will dive into the details of magnetic field and electric field. And then finally, we have the gravity. We have the gravity because of the curvature of the space. Okay? So, of course, we are focusing at this one. Okay? I need you to understand this. We have 4 types of forces: strong nuclear force, the weak nuclear force, the electromagnetic force, and gravity. So, in this particular course, we are focusing at electromagnetic force. So, what is electromagnetism? It is the electric and magnet. You know, you played around with magnet before, and then you also know about electricity. But the existence of electric and magnetism, they must exist together. They are coupled. Okay, so electric is due to the presence of charged particles, but magnetism exists due to the movement of the charged particles. I need you to remember this. So if my hand is a charged body, but it stays here, okay, then it is producing the electric field. So let's say if I have an electron here, let's say this is positively charged, and then this is negatively charged. So this guy is giving some sort of electric field. You can think of like your crush. When I see my crush over there, she is giving me some sort of aura. So that particular aura is analogous to the electric field. So when I get closer, let's say if I am the electron, when I get closer to her, I'm becoming more shy. So that degree of shyness is analogous to force. But when the charged particle is moving, okay, when the charged body, not particle, sorry, when the charged body is moving, let's say if my crush is moving, if she is moving, she creates another field, which is the magnetic field. She creates an attraction. So it is something like that. So I hope you remember this kind of example. So it is not possible to separate between electricity and magnetism. So they have to appear at the same time. That's why we have the photon, which is when we have the electric field. You know, I don't know how to say. Let's say if the green pointer is my electron, if it is not moving, it is producing the electric field around it. So it will attract positively charged particles, right? But when it is moving like that, so it is creating the magnetic field. So that's why, you know, we have a device which is known as, I don't know, we have the coil, you know, the bell, or the bell ring. You know? Inside the bell, we have the, electromagnetism is going on. You know, you wind the wire up to 1,000 times, and then it will, when you give some sort of current, and then it will attract the hammer of the bell. And then once it is released, then it will not, the bell, okay, enables communication. Do you know the reason why? Because of the photon itself. Okay, the photon itself is consists of electric field and magnetic field. So it gives you communication. And then next, okay, the lecturers. So I'm telling you, this is me. I'll be covering electric charge, electric field, Gauss law, electric potential, and capacitance. From the electric charge, you will learn about proton and electrons in depth. You will learn how to build a charged body using protons and electrons. You know, I've also demonstrated you the gold leaf experiment because I want to prove the photoelectric effect, if you could remember, but it failed because of the environment. I'll try to bring that maybe later, just to show you about the electrical charge. And then the electric field, I've mentioned about my crush just now. So electric field, and then Gauss law. I won't be able to explain about Gauss law now, maybe later. So electric potential and capacitance. So electric potential is more, if you want to understand electric potential, the idea is like the lightning. Why does the lightning strikes on the ground instead of to the outer space? Okay. So once you have learned electric potential, then you should be able to answer that. Okay. Then we have the capacitance. Capacitance is just like a battery. I mean, a short-lived battery. If you have a battery cell, you are using the chemical reactions. You are using the chemical energy to release the electrons. But for the capacitor, you are using the electric field to store the electrons. But the storage is short while, it's just a short while. When you use capacitor as a battery, so you will only be able to use it in a short while. in a matter of seconds. But if you use the actual battery, the Energizer, Everready, or whatsoever, that is based on chemical reactions or chemical energy. But the idea is the same. But we are using the different way of storing the electrons. We store using chemical energy, or we store the electricity using electric field. I'll explain that later. So Dr. Ramzan will cover current and resistance, DC circuit, magnetic field. Okay, so you will learn a lot about magnet under Dr. Ramzan, and Dr. Nabiha will teach you the Faraday's law, inductance, AC circuit, and EM wave. So the third section here, because this is an introductory course, the last one is related to the Maxwell equation. If you heard about Maxwell equation, well, it's okay. If you still don't understand about Maxwell equation, which is okay, but the last part is a portion of Maxwell equations. Okay. Later, Dr. Nabiha will teach you about that. So of course, our class is at DKV, DKW, and DKS. So I will assist you with the concept test on every Friday. It's just like the tutorial. It's just that we don't have any extra tutors. So that's why we are not having any tutorials. But I'll still do the tutorial. Not really a tutorial, it's the concept test. I will not mark you, but at least one lecture will have at least 10 questions. Okay? 10 questions, at least 10 questions. We will go through all of them, and then I will select one of these questions as your assignment. So I will assist you to do the assignment. Meaning to say, we will do the concept test. For example, this week we will go through lecture number 1. So for lecture number 1, we have 10 questions, 10 concept tests. And then we will go through and discuss about that during the class. So for example, for question number 1, I'll give you like 15 minutes to answer, not 15 minutes, like 5 to 10 minutes. I'll give you 5 to 10 minutes to answer the questions. And then we will use WhatsApp call. And then you try to give me the answer because it is an objective question. So based on the statistics, I will know whether you understand the concept or not. And then we will go through the question again. We will discuss about the questions just to make sure that you understand the question. And then I need some sort of discussion among you yourself, and then you help your friends to answer the question. Like I'm training you as a teacher as well. So at least we will have 10 questions, and then one of the questions will not be discussed because it is an assignment, right? But I will assist you. And then when you go back to your hostel, I'll give you some extra time to answer the question, and then you have to submit the full solution to me. I hope that it is fair, right? Even though the question is objective, but once I have selected the question as your assignment question, as one of the assignment questions, you have to assume that as a subjective question. You need to show me the workings. So I'm not expecting to see like A, B, C. So we have 3 assignments. The assignment description just now is only applicable for me, okay? So under Dr. Ramzan or Dr. Nabiha, it's up to them. So my assignment is based on concept problems. So we have 2 tests. To be honest, we still haven't decided when to do the test and who is going to handle the test. So I'll give you the update later, okay? And then finally, I will assist you on completing your assignment, okay? Just to make sure that you understand the concept. Next. The math requirements. So these are the math requirements, okay? The math requirements. So you have to master the following math topics. So vector operation in the phase space. Do you understand the meaning of phase space? We are actually living in the phase space. 3-dimensional world is the phase space. So we are actually living in the phase space. And then you have to understand about unit vectors. We have the unit vector, r cap. Okay, I repeat, yeah. We denote vectors using the bold font. Are you clear? I'm not going to use the arrow on top of the variable. I'm using the bold font. That is my style. And then V is the phase space. This is our 3-dimensional world is considered as the phase space. And then which is the subset of R3, which is 3 dimension. That's all. So R is real axis. So we are not going to deal with the complex axis anymore, like in 103. Okay. So here, the phase space is three-dimensional. So the vector operations, for example, the vector addition. So you have two or more vectors, you add them together. You have to consider the components as well, according to the basis vectors. Okay, the basis vectors is given by I, J, K. They are known as the basis vectors. Okay, so we will assume that the basis vectors I, J, K are orthogonal to each other, which is three-dimensional. Okay, for example, this is our three-dimensional space, like that and like that. So this is I cap, this is J cap, and let's make this as K. Okay, I, K, this is J. So the magnitude of your basis vector is equal to 1. Okay, 1. And then you, for example, this is the origin, and then this is U at this particular point. So your position is R. In my notation here, I'm using the arrow above the variable because I'm not able to do bold fonts in my writing. Okay, so I'm using the arrow here. But in my lecture slide, I'm using the bold font. Okay? Remember, when you answer the question, you just put the arrow on top of the variable. Okay? Just to make sure that it is a vector. So this is U in the space, and then we have the vector emerging from the origin towards U. Okay, this is the vector. So this is the vector R. So it is situated here, for example. This is the point. Can you imagine this? So it is three-dimensional. You just imagine this in three-dimensional. Okay, this is U. So R is equals to xi plus yj plus zk. This is something that you have learned in 101, if I'm not mistaken. We can also have another phase space, which is like that. So this is your I, this is your J, this is your K. So here it is orthogonal. For this one, it is orthogonal. It is 90 degrees. One basis vector is orthogonal to each other. So, which is our space. But here, the angles between the basis vectors are not the same. Again, the modulus of this one is 1, the modulus of this one is 1, so on. So, I hope you are clear with that. So, we are not focusing on this. I'm just giving you some information. So, you don't have to copy anything. Okay? I'll share you my writing here, as usual. But, well, of course, you are learning, so it's okay if you want to copy. Okay. Next. So we have the vector A, we have the component of vector A. The component of vector A is given by A sub x. Well, of course, you can always replace the variable A with anything else. Let's say you want to replace with the position vector. If it is the position vector R, then you replace A sub x with x. And you replace A sub y with y, and so on. Okay, for three-dimensional, you only have up to z. And then the unit vector, you need to understand why do we have the unit vector. The unit vector, listen to me, okay? You have the vector, and then you also have another term, which is the unit vector. The vector itself consists of the magnitude and direction. Let's say if I punch your face, so we have the strength of the force, say if I punch my face, and then we also have the direction of my punch, whether I'm punching my face from here, or down here. So we have the direction and the magnitude, okay? How do we specify the magnitude? We specify the magnitude using the modulus sign here, which is the magnitude or the norm. In mathematics, we never call it as magnitude, we call it as norm, N-O-R-M, norm. The norm of the vector. is the magnitude. Let's say if this is my punch, F, the vector F is my punch. So the magnitude is the modulus F. And the direction will be the unit vector of the vector F. Okay, so that's why it is unit vector. The magnitude is equals to 1. Because later, you can reuse the direction. Let's say if you have your friends, me and your friends. Okay, now John, I want you to punch even harder, but it must be in the same direction as mine. So John will ask me, Ravi, what is the direction? So the direction is I, or J, or K. So now John knows where to punch my face. I'm giving you this example to allow you to understand this. Are you clear, guys? Okay. I have to introduce you with this because physics is not just about talking. Blah, blah, blah. I'm a physicist. You have to do the math working. Okay. You need the calculus. Okay. And then next, the vector norm. This is, of course, this is the rex. We've learned this before. And then last one, we have the distance between two positions. The distance between two positions. So let's say me is located at R0 and your friend is located at R1. So the distance between me and your friends is given by the location here. It is just like the magnitude. Well, it is the magnitude, but we use the double vertical line to indicate the separation between two vectors. Okay, so this is the formula. So x1 is the x-axis component of R1, y1 is the y-axis component of R1, and so on. Is this intuitive? Is it logic to you? Does it look logic? So if you have questions, you can always ask me. Okay. And then next we have the path integral. Before I dive into path integral, you need to understand the meaning of integration itself. This is me. I do have a volume. How do you calculate my volume? Well, obviously you can always use you can always use calculus. The reason why we use calculus because it comes from the word calculus. It's a calculi. You know, when you got problems with your kidney, you have like the kidney stone. The small stone is known as the calculus. So it has the same meaning, no? So you divide the volume into smaller sections, and then, for example, you create a differential volume. You create a small volume, a small box of the same dimension, L, 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 you know, the box, no? Box or cuboid. And then you try to fit the boxes inside my body. And then you can always count how many boxes are needed to fill in my body. So the volume of the box is given by the number of boxes that you fit inside my body times the volume of the small portion of the box. So I'll show you an example here. Okay, let's say if I want to calculate the volume of this chunk. So using calculus, we define a small area here. This is dy, this is dz, and then you duplicate the box here. You duplicate, for example, and then I fit the box here, 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 and so on. And then you count how many boxes are needed to fill in the body. And then you, let's say it is n, then you multiply with the area, dy times dz. This is the area of the box, huh? The vertical, the height times the width, dy dz. You have to multiply. You have to put n. So n is the number of boxes needed to fill in the body here. So, well, let's say this is the box. So this is the volume. Okay, this is the volume. The volume, the approximated volume. Let's say if you make the box as small as possible. I mean, theoretically small, like the points. You know, the points in space, it has no volume, right? The point in space, there's no volume for a point. It is just a theoretical depiction of the position of a body in space. So the point itself has no volume. So it has no volume. So you just assume that the box here, you squeeze it, you make it smaller, 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 and smaller, so that it's just about the same size of a point. Even though the point has no size, but it is infinitesimally small, infinitesimally small. So and then you fit the boxes inside the area here. So meaning to say you have already approximated the volume of the sphere. Not the sphere, the volume of the body here. Okay? So that is the idea. Okay? So now, any questions so far? You can ask on Telegram if you wish. I'm giving you like 30 seconds to ask. So now we talk about the path integral. So the path integral is related to this. It is something similar. Let's say if you, this is you, okay, you are carrying the box. So this is the box, okay, you are carrying your laptop, not box, okay, we change the situation. You are carrying your laptop. And then this is the service center. This is the service center. So you have 3 different paths. Here to here, here directly, and then we have path number 3. So the 3 paths have the different distance, right? Of course, this is the shortest one. This is the longest one. Okay, this is medium. Okay, so depending on the situation, whether you use this path A or path B or path C, then the work done, the energy spent by you to transport your laptop to the service center here, so will be different. Of course, this is the shortest one. Especially during Ramadan, you prefer path A, right? Because it will require you the least energy. So meaning to say, if you zoom this even closer, let's say if I take path A, this one, okay, you can always divide the path into smaller chunks, you know, the differential lines, the small chunks. So because the line itself is like that, right? How do you estimate the length of the path? Of course, you need to divide into smaller, you need to approximate the line with a line because you know the length of a line, right? So you just make it smaller and then let me try to do this one, and then this one, this one, this one. So let's say this is L1, L2, L3. L is the length of the line, you know, the small line. So let's say if I divide into smaller line here, line. So the length of the line is L. So this is L1. So I need to sum all of the contributions, L1, LK. So we need to say it's L1 plus L2 plus L3 is approximately equals to the length of the line. Okay. If you got problems with understanding the meaning of this, you can always ask me again and again. Okay. My room is 210. You can always come. You can always come in groups, so I can re-explain this. So meaning to say, we can also define the function E as the energy. Okay, the energy spent by you for traveling in a single straight line here. You know, the straight line, the short line here. So it requires energy, right? Even though it is small, so you need to spend some energy to move from one line to another, from here to here. So because you know the distance of the line, so you can the energy times L1. This is the work done. No, sorry, not the energy. Should be the force. Sorry, the force. Force times the distance is the energy spent by you for a unit line. And then you add another one, force times L2, the contribution for the second distance, the second line, and then you add them all together. So when you use calculus, you make it small, 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 okay? Because you want to simplify things. Because you don't know the length of the complex line, so you break down the line into smaller chunks. So that small chunk is a simple geometry, which is the line. So you know the distance of the line directly, right? So when you take the limit as L here, the limit as L approaches 0, which is very small, then you have an accurate representation of the work done by path A. So the work done by path B is different. Okay, so normally we denote line integral as this, the S, because integration is summation, right? So that's why you have the S symbol here. And then you have your force times dl. This is the work done. From your form 5, they will just say the work done is equal to F times L. Okay, that is the baby term of work done. So now you are all grown-ups. So I'm going to introduce you to the calculus. Let's say if the path is a closed path. So it is a closed path is known as a contour. Okay, so this is important if you are taking geophysics. So a contour is given by a line that is connected to its end. So this is the starting point. So go back. So for here, we denote the integration C here. So the C here represents the line here. So for example, if you want to integrate over path A, so you set A here. So now I understood that you are integrating over path A. So let's say if you want to integrate over path C, then you replace this with C. Okay? If the path itself is a closed path, which is a contour, then you just put 0 like that. 0 like a circle at the center. Okay? So this is the contour integral. And then in the next lesson, I'll introduce you to the surface integral.